Now we're going to discuss about one more topic on stress, strain, and deformation in a straight or uniform sectional bar. So here, when a bar is subjected to a tensile load, so here a bar is subjected to tensile load as shown in the figure A, it will elongate by an amount by delta L. So that means here you can see the extension of the bar will going to be takes place by the delta L when the load is applied tensile. Similarly, when the load is applied with the compressive load, then there will be a decrease in length of the bar. So then the delta L is the length which will going to be reduced in length of the bar. As shown, it will be shortened by the amount delta L. Let capital P is the applied load. So this is the capital P, which is the applied load. With it, here in this case it is the tensile load, and here in this case it is the compressive load. So naturally, a capital A is the area of cross section of bar. So small L will be the original length of the bar. So this is the small L, which will going to be the original length of the bar. And here this length will be the small L, which is the original length of the bar. And delta L is the change in length. So here, so this length is delta L, which is the extension. And this is the delta L, which is in reduction because due to the compressive load. Extension is due to the tensile load. Now, according to, so what is the stress which will going to be takes place? Sigma will be equal to load by the area of cross section. So what is the load? The applied load capital P, and area of cross section is capital A. So sigma is equal to P by A, and strain will be equal to change in length by the original length of the bar. So delta L by L. So according to the Hooke's law, what it says, it is the linear or longitudinal stress by the linear or longitudinal strain. So in other words, in general, what we say is E is equal to sigma by epsilon. So what that is equal to, what is sigma, which is equal to P by A, and what is epsilon, which is delta L by L. So that is P by A into divided by L by delta L by L. When you cross multiply, you will go into L will go to the numerator and delta L go to the denominator. So capital E will be equal to P into L by A into delta L. So therefore, Young's modulus will be equal to P into L by A into delta L. But what we want, according to the requirement, what we need to, we know stress, we have defined strain, and we want the deformation. So what is the deformation? Deformation is nothing but delta L. Therefore, extension or shortening of the bar, you cross multiply here, delta will go to this side, E will go to become denominator. Therefore, delta will be equal to capital P into small l by capital A into capital E. So delta L will be equal to P into small l by capital A into E. So now we are going to take one simple problem wherein a steel bar of 2 meter long and 150 mm square is the cross section is subjected to an axial pull of 15 kilonewton. So find the elongation of the bar. So you need to find out what is delta L. So he has given take E equals 200 gigapascal. So first what we need to do, we need to convert all the parameters into SI units. So to do that, first here he says the length of the bar is 2 meters. So since he has given the cross sectional area as mm square, so you convert this 2 meters into mm. So length will be equal to 2 meters, that will be equal to 1 meter is equal to 1000 mm. So 2 into 10 to the power of 3 mm, which is equal to 2000 mm. So area of cross section of the bar. So since we have converted L into mm, so it is 150 mm square. So A will be equal to 150 mm square. Is subjected to an axial pull of 15 kilonewton. So axial pull P will be equal to 15 kilonewton. 1 kilonewton is equal to 10 to the power of 3 Newton. Therefore, 15 into 10 to the power of 3 Newton. So what is Young's modulus? Young's modulus is nothing but E is equal to 200 GPa. So what does it mean? So 200 into 1 GPa is equal to 10 to the power of 9 Newton per meter square. So 200 into 10 to the power of 9, which is Newton, divided by meter square. 1 meter square will be equal to 10 to the power of 6 mm square. So divided by 10 to the power of 6. So 10 to the power of 6, 10 to the power of 9, we are going to left out with 10 to the power of 3. 200 into 10 to the power of 3 Newton per mm square. So 1 GPa can be written as 1 Newton per mm. 10 to the power of 10 to the power of 6 Newton per meter square is equal to 1 Newton per mm square. So here what happens? 200 into 10 to the power of 3 will going to become, so 2 into 10 to the power of 5 Newton per mm square. So here the conversion factor is also shown. 10 to the power of 6 Newton per meter square is equal to 10 to the power of 6 divided by 1000 square. So that is equal to 10 to the power of 6 by 10 to the power of 6, which will be equal to 1 Newton per mm square. 1 GPa is nothing but 1 Newton per mm square. 200 GPa will be equal to 200 in Newton square. So here, so 200 into 10 to the power of 3 Newton per mm square. So therefore, this is how these are the data which I am converting. So 200 into 10 to the power of 3 Newton per mm square. So now what I need to do is to apply the formula now. So to do that, so what is stress? Stress is given by sigma is equal to axial pull by area of cross section of the bar. So P by A. So axial pull is 15 into 10 to the power of 3 divided by area of cross section is 150. So you are going to get it as 100 Newton per mm square. Sigma is equal to 100 Newton per mm square. Young's modulus E will be equal to stress divided by strain, that is equal to sigma by epsilon. So we know the Young's modulus, which has been given 210 to the power of 3 is equal to 100, because the stress what you got here is 100 divided by epsilon. So on cross multiplication, epsilon strain will be equal to 5 into 10 to the power of minus 4. Since it is strain, so it is unitless. So also we can say epsilon will be equal to change in length by the original length, which is equal to delta L by L. Therefore, what is epsilon? Epsilon given, epsilon what we got from here is 5 into 10 to the power of minus 4. So 5 into 10 to the power of minus 4 is equal to, we don't know what is the delta L, because that is the one which I need to find out, which is find the elongation of the bar. So naturally delta L we need to find out. So that is equal to delta L by what is the original length of the member, which is equal to 2 meters. The 2 meters, when it is converted into mm, it will be going to become 2000. Therefore, change in length or the elongation of the bar delta L will be equal to 1 mm. So this is how you will be able to find the solution. But we can do by very simple way, elongation of the bar, which is equal to delta L equal capital P into capital small l by capital A into E. So we know 15 into 10 to the power of 3, which is P. We know that length of the member is 2000 divided by area is 150, and Young's modulus is 2 into 10 to the power of 5, or 200 into 10 to the power of 3. On simplification, delta L what you are going to get is 1 mm. So this is how you will be able to find the solution for this particular problem. So now we go for the one more problem on this. An alloy bar of 1 meter long, this is the second problem, an alloy bar of 1 meter long, so and 20 mm by 10 mm in area of cross section. So here the cross sectional area what you have is of the rectangular cross section is subjected to a compressive load of 20 kilonewton. So if the modulus of elasticity for the alloy is 100 GPa, find the decrease in length of the bar. Why he has asked for the decrease in length of the bar? So that is basically because it is the compressive load is acting on the member. From our previous videos, when we are discussing about the theory, we talked about the compressive load. That means always when the two opposite forces pushes each other, so it will go into the material comes nearer, so that there will be a decrease in length of the member. So that is the reason why we need to find out the decrease in length of the bar. So to find out that, for here he has given the length of the bar as 1 meter. So you convert meter into mm, that is equal to 1000 mm, or 1 into 10 to the power of 3 mm. And the area of the cross section of the member is 20 mm by 10 mm. So area of cross section capital A is 20 mm by 10 mm. So that will be equal to 20 into 10, which is equal to 200 mm square. It should not be mm cube, it is mm square. That is because area of cross section. And then the compressive load is 20 kilonewton. It should be 20 into 10 to the power of 3. So it is 20 into 10 to the power of 3 Newton mm. And the modulus of elasticity for the alloy is 100 GPa, 100 into 10 to the power of 3 Newton per mm square. In our previous, in the first problem, we discussed about the conversion of GPa into Newton per mm square. So apply the same concept. So 100 into 1 gigapascal will be equal to 10 to the power of 3, 9 Newton per mm square. So convert this meter square into mm square, it will become 10 to the power of 6. So when it is taken to the numerator, it becomes -6. So 100 into 10 to the power of 3 Newton per mm square. So then decrease in length of the bar or shortening of the bar delta L will be equal to P into L by capital A into E, that is 20 into 10 to the power of 3 into length of the member is 100,000 divided by area is 200 into 100 into 10 to the power of 3, which is equal to 1 mm. So this is how you will be able to find the solution for this particular problem. In our next video, we will continue with the problems on the stress and strain. Thank you.